The greatest success story in space exploration has a name, and it's not the James Webb Space Telescope. No, the true pioneers of space travel are the two legendary Voyager probes, which have been journeying through the vast, uncharted expanses of space for an incredible 47 years. These probes have continuously expanded our understanding, giving us new insights into previously unknown cosmic worlds. Acting as humanity's most distant outposts, the identical sister probes have now ventured beyond the solar system into interstellar space, revealing that the outer regions of our solar system are far stranger and more mysterious than we could have ever imagined. But how can we explain the puzzling differences recorded by the probes at the threshold of our home system? And what about the enormous, enigmatic, wrinkled structures hidden within the Heliosphere, waiting to be discovered? Looking back, the year 1977 feels like an entirely different era. It was the year Jimmy Carter assumed the U.S. presidency, the last year that the guillotine was used in France, and when the cult classic film Rocky claimed 3 Oscars. But beyond these memorable moments, something even more significant occurred in the realm of space exploration. NASA launched the Voyager 1 and Voyager 2 space probes, which would go on to reshape our understanding of the universe. Voyager 2 was the first to lift off on August 20, 1977, beginning its journey to explore the largely unknown and mysterious outer planetary regions. Voyager 1 followed 16 days later, embarking on a different path through the cosmos. At the time, no one could have possibly foreseen that these launches would mark the beginning of the longest, most enduring mission in the history of modern space travel. Initially, the mission was not expected to take Voyager 1 and 2 on such an epic journey. Fast forward to today, and Voyager 1 is a staggering 24.63 billion kilometers from the Sun, with Voyager 2 trailing at 20.59 billion kilometers. These spacecraft were initially tasked with studying the outer planets of the solar system, not venturing into the unexplored depths of space. In fact, communication problems with Voyager 2 right from the start led to some concern. Fortunately, NASA experts managed to resolve these issues quickly, clearing the path for what would become an extraordinary and record-breaking mission. We now live in an era where the James Webb Space Telescope presents us with incredibly detailed images of the distant outer planets. However, nearly 50 years ago, the situation was entirely different. Our knowledge of the far-off planetary systems was extremely limited. Voyager 1 and 2's first objectives were to explore the Jupiter and Saturn systems, providing scientists on Earth with a treasure trove of measurements and thousands of images. These missions fundamentally transformed our understanding of the gigantic gas giant Jupiter and the iconic ringed planet Saturn. While Voyager 1 was eventually set on a course toward interstellar space, Voyager 2 still had a few exciting stopovers ahead. In the spring of 1981, a corrective maneuver was executed, and Voyager 2 was sent on its way to Uranus, reaching the planet on January 24, 1986. By this time, the probe had already far exceeded its originally predicted lifespan, yet it continued to provide invaluable data. Not only did it closely examine Uranus, but it also discovered 10 previously unknown moons orbiting the distant ice giant. Voyager 2's exploration didn't end there. The next stop was Neptune, where the probe captured over 9,000 breathtaking images of the outermost planet in our solar system. This journey added 9 newly discovered moons to our star maps and revealed that Triton, Neptune's largest moon, had a diameter much smaller than previously thought. Moreover, Triton's surface, with its geysers regularly spitting liquid nitrogen, presented new mysteries to unravel. To reach the next significant milestone in the Voyager mission, entry into interstellar space, we must look back to the year 2012. This distant, cosmic realm, which is beyond the influence of the Sun, is filled with interstellar medium, a mixture of dust, ionized gas, and molecular particles. Voyager 1 crossed the boundary of the solar system in 2012, officially entering interstellar space. 6 years later, Voyager 2 followed in November 2018. These probes, still operational, are now conducting groundbreaking measurements of the interstellar medium, allowing scientists to compare the data gathered from two different regions of this distant frontier. The discoveries made at the edge of the solar system have been nothing short of extraordinary. Voyager 1 revealed that the interstellar magnetic field was almost 3 times stronger than scientists had previously assumed, and the pressure exerted by interstellar particles on the heliosphere was 10 times greater than expected. However, due to a malfunction of the plasma temperature sensor on Voyager 1 in the 1980s, the exact details remained elusive. This is where Voyager 2 came into play, as its plasma sensor remained functional, providing critical insights into the nature of the interstellar plasma as it crossed the heliopause. Voyager 2 revealed that the plasma density increased significantly, while at the same time, the plasma slowed down and heated up beyond the heliopause, where temperatures reached an astonishing 30,000 degrees Celsius. As the Voyager probes ventured through the heliosphere, they encountered perplexing phenomena. Voyager 1 observed dense clusters of interstellar particles, while Voyager 2 detected a continuous stream of particles stretching over 150 million kilometers. Despite the differences in their measurements, both probes confirmed that the heliopause, the boundary separating our solar system from interstellar space, is far more complex and dynamic than we had ever envisioned. The heliopause is wrinkled, with enormous folds stretching billions of kilometers across space. In 2019, researchers at Princeton University analyzed data from both Voyager probes and discovered that these folds were created by high-energy particles colliding with solar plasma. These structures are constantly shifting, expanding, and reshaping themselves. Though the Voyager probes are moving too fast to be caught by these folds, they continue to offer us invaluable insights into the dynamic nature of the outermost regions of the solar system. Despite their advanced age and incredible distance from Earth, Voyager 1 and Voyager 2 are still transmitting data back to us. Their remarkable journeys are far from over, and the information they send will continue to revolutionize our understanding of the universe.